All right, guys, look at this.
All right.
I think a lot of you probably checked the key online already, but so let me mark the answers, and then any you need an explanation on, let me know. And then 4 was A, 5 is B, and 6 is E. So guys, first page, well, first half of the page for you guys. Number 1, did you guys get stuck on that? It's asking where the derivative has a maximum, which means you have to go all the way to the second derivative to find the maximum. Are we okay on that? A lot of this is really reading the question carefully and making sure you're answering what you're being asked. All right, so 1 through 6. Any you need an explanation? Number 2? Ah, yeah, good. This one's tricky. So did you go through and do your number line and get the 0.0 and 2?
Yeah.
Okay. The thing that's different is this has a closed interval. So those endpoints could potentially be maximums or minimums. So what you'd have to do, I think it was 2 was where, was it 0 or 2 were the maximum?
2.
2.
It was 0.
Was it 0? Okay, so 0 would give you, like 0 would give you 12, right? What you have to do is plug in -2 and plug in 4 and see if either of those give you a value bigger than 12. And I can tell you, -2 gives you -8, but 4 gives you 28. So that is actually where the maximum occurs. Guys, you haven't done any over closed intervals, so
It's not like a relative maximum, it's just a high point in that area.
exactly. Yep. Yeah. 3, sure. 3 is one of these lovely. I'm going to just go to a new slide so I have room to write. This one takes up a little space. Okay, so you get that we'd have to find the derivative, right? Okay, and product rule kind of combined with chain rule. Are we okay with that? So x minus 3 to the 4 times. Are you okay with me writing it this way? 5 times x plus 2 to the 4. Okay. Plus 2 to the 5th. And then this would be 4 x minus 3 cubed. Good to that one, right? Okay. This is where we then have to do that weird factoring, like the fancy factoring. Like I see, okay, they both have x minus 3s. I could take 3 of them out. Okay. You see, they both have the x plus 2s. Take 4 of those out, and then left, I have an x minus 3. I have the 5. I have an x plus 2. And I have the 4. Are you with me there? Okay. So this is really 5x minus 15 plus 4x plus 8. So that's 9x minus 7. 3 factors mean 3 critical values. Yep. Okay. Yeah, no problem. All right, guys. What else? 1 through 6? Anything?
You go with 5.
5, sure. Okay, guys. This is technically called Rolle's theorem, but you can do this visually without knowing what that theorem is. So we know A and B are 2 different values. I don't know what they are, so I'm just going to put them somewhere on my x-axis. I'm going to say there's A, there's B. And I know that f of A is 1 and f of B is 1. Okay? these 2 points are connected with a continuous function here. So how that could happen, it could be something like that. It could be that. It could be a line. It could be something that actually crosses the x-axis. So those are sort of your minimalist options without like a bunch of different maxes and mins happening in between.
It says it has a degree greater than 2 though, so it can't be a line.
I mean, something weird could happen afterwards. Even with the line, you still get the right answer. We don't know that we're going to see everything between A and B.
Yeah.
Okay. All right, so does f of x have to equal 0? So does that graph, all my options there, does it have to cross the x-axis? Does not, okay. Does the first derivative have to equal 0? Okay, if the first derivative is 0, that means you have a horizontal tangent line because it was a maximum or a minimum.
Yes.
Yeah, there's got to be a max or a min between A and B. Or if it happened to be the horizontal line in between, like let's say that was our equation, what's the derivative of that? 0. So, yes, first derivative somewhere in there, it's either going to be a maximum, a minimum, horizontal tangent.
Oh, I did read the must be true for at least one value of x. That is the whole function.
Ah, okay. And then the third one, the second derivative has to equal 0. That would mean that you have a change in concavity. That doesn't have to happen in between there. So 2 lines. Making a picture for questions like 5 and 6 is very helpful. 6, sure. All right, so again, I'll make a little sketch. We know f of 2 is -5. I'm just going to kind of approximate here. F of 5 is 5. F of 9 is -5. So what has to be true? So again, I'm going to connect them in kind of the most basic way just to see. And it says it's differentiable on that interval, so we know it's continuous. Okay. Does the function have at least 2 zeros? Like, is it going to cross the x-axis at least once? Yes. Okay. Will it have at least one horizontal tangent? Yes. Okay, for some c between 2 and 5, so we're looking in this little window here, will my y value be 3? So let's think about if I sketch that in. Does it, do you see it? Like, okay, somewhere in there it's going to have to happen. Because I'm going from a -5 to a 5, and it's continuous. So somewhere it's going to hit a value of 3.
Oh.
Does that make sense? Okay. I feel like with these 1, 2, and 3 questions, you're always super sure about 2 of them. And then there's one that you're like, maybe. And that makes those questions very hard. Nope, just some function value. It kind of looks like part of the IDT.
Yeah, that's what I was
yeah. All right, we good 1 through 6?
4.
4. Okay, so these graphs are of the derivatives. Okay, so what is happening in this section of the original graph based on this derivative?
It's negative, so.
Yes, so original would be decreasing there, right? Then what is it doing? So then it's going to increase, and then what's it doing? Okay, so there's a lovely sketch of what that function might look like.
Okay.
If we go to the, do you see it? Okay. All right, let's move on to 7. 7 was B, 8 is C, 9 is B, and 10 is B. All right, guys, questions on 7 through 10?
How does 10
How does 10 work? Okay. So this section, what is the first derivative doing?
Well, it's increasing.
Okay, so we know for this one.
It's possible.
And then what kind of concavity is that? Is that concave up or concave down? Yeah, kind of like, so that means the second derivative there is also greater than 0. We want first derivative greater than 0, but second derivative negative. So I need the other increasing part that is concave down.
Okay.
Do you see it? Yep. Okay. What else, guys? 7 through 10? Yeah. Was that 8? Okay. Early in the morning to count fingers there. Did you get that there were 2 places that it had a point of inflection? Or were you just not sure on this one? Just not sure? Okay. Yeah, I got it. So for 8, if you do, like, I'm going to rewrite this. So first derivative would be negative 2x to the negative 3 plus 3x to the negative 4. Are you okay with that? Okay, and then we need the second derivative.
Yeah.
So that would be 6x to the negative 4th minus 12x to the negative 5th.
Oh, yeah.
Yeah? Okay. If I rewrote this, that would be 6 over x to the 4th minus 12 over x to the 5th. And if I combine those, I'd have 6x minus 12 all over x to the 5th. Are you okay with that? Okay. Your critical values, remember, are where your derivative equals 0 or is undefined. So there's 2 critical numbers here. It's undefined at 0 because of the denominator, and then it would equal 0 at 2. Okay? Potentially, those are both points of inflection. One of them is not, though. How do I know one is for sure not a point of inflection? Because it's undefined. Yeah, since this one was undefined, it ends up not being a point of inflection. Like your number line goes positive, negative, positive, like it changes. But because it's undefined, it can't actually be a point of inflection. Okay? All right. What else, guys? Oh, I found a common denominator. So like I took this fraction here. I took numerator and denominator.
Oh.
Yeah. All that algebra stuff. Okay, keep going. So I said skip 11. 12 was B. And 13 was A. Either of those issues? Okay. Okay. Look at how much better you've gotten at the graph part since the first day I had you try that. All right, and then I said skip 14. 15 was D, and 16 was E. Did you guys get 15? It's just really slow down, think through exactly what you know. What is the original? What is the first derivative? What is the second derivative? What are those things telling you?
Oh, yeah, that makes sense.
Because it's like f of 1, well, that's 0. F prime of 1, it's increasing, so it'd have to be positive. F double prime of 1, it's concave down, so we know that's negative. Well, that graph is kind of key. All right. Any other questions on the Think Quiz review?
You go over 16.
16, sure. All right, so if I'm looking at concavity, that means I'm looking at the second derivative. Okay. Let's see. 2, my first derivative would be 12x cubed minus 48x squared plus 48x. Okay. Second derivative minus 96x. You okay with that? All right, I could take a 12 out to kind of help me a little bit. 3x squared minus, what is that? 8x? Yeah, thanks. Plus 4, and then you can factor. I think we end up with minus 2 minus 2. Are you okay with that part?
Yeah.
Then we're looking at 2 and 2/3 on the number line. If I plug 0 in, I would get negative times a negative. It's going to alternate. And it said, when is it concave down? I put them in the wrong order, obviously. Wow, okay, there. From 2/3 to 2. Yes. Was it just the factoring or?
Yeah.
Okay. So concave up can either be increasing or decreasing, like either one. Same with concave down. So we don't know what it's doing. I mean, we could go back and look at the first derivative to figure that out. But it's some sort of something happening in here, something happening in here, and something happening in here. But I don't know which piece. You know what I mean? Yeah.
I can help with the delta.
Yes, you would ask me all the like graphics, right? Okay, so don't forget about your delta mat, second attempts, all that good stuff, okay?